In the vast expanse of our solar system, where celestial wonders ignite our imagination, there exists a planet of captivating beauty and enigmatic nature: Venus. Often referred to as Earth's sister planet, Venus has captivated astronomers and stargazers for centuries, its radiant glow piercing the twilight sky. Its ethereal beauty, reminiscent of a celestial diamond, has inspired countless myths, legends, and artistic expressions throughout human history. Named after the Roman goddess of love and beauty, Venus holds a prominent place in our collective consciousness. Its brilliance, outshone only by the sun and moon, has earned it the titles of both the morning star and the evening star, gracing the heavens as a harbinger of dawn and dusk. Yet, beneath this alluring facade lies a world of scorching heat, crushing pressure, and a toxic atmosphere that belies its celestial charm. At first glance, Venus and Earth appear remarkably similar. They share a comparable size, mass, and composition, suggesting a shared origin in the swirling cloud of gas and dust that gave birth to our solar system. Both planets possess atmospheres, albeit vastly different in nature, and both bear the scars of past volcanic activity. For a brief period in their early histories, it is even possible that Venus and Earth followed similar evolutionary paths, their surfaces adorned with vast oceans of liquid water. However, as time wore on, the destinies of these two planetary siblings diverged dramatically. While Earth evolved into a cradle of life, its surface teeming with a rich tapestry of flora and fauna, Venus embarked on a different trajectory, transforming into a scorching inferno shrouded in a dense, toxic atmosphere. Understanding why and how these two seemingly similar planets met such drastically different fates has become one of the most compelling questions in planetary science. Long before the invention of the telescope, our ancestors looked up at the night sky and saw the same celestial tapestry that has captivated humanity for millennia. Among the twinkling stars and the ethereal glow of the Milky Way, one object shone with a brilliance that rivaled even the moon itself: Venus. Its radiant light, like a celestial torch cutting through the darkness, has captivated skywatchers for centuries, inspiring awe and wonder in equal measure. To ancient civilizations, Venus was more than just a bright light in the sky. It was a celestial object of immense significance, imbued with mythical and religious importance. In Mesopotamian mythology, Venus was associated with Ishtar, the goddess of love, beauty, and war. The ancient Egyptians identified Venus with the goddess Hathor, a deity of joy, motherhood, and the sky. Across cultures and continents, Venus has held a prominent place in the human imagination, its celestial movements tracked and revered by ancient astronomers. As astronomical observations grew more precise, it became clear that Venus's movements were not perfectly cyclical. The planet's apparent brightness, for example, varied significantly over time, a phenomenon that could not be explained by its simple movement across the sky. These subtle variations in brightness, along with the planet's elusive phases, hinted at a more complex relationship between Venus, Earth, and the Sun. It was the Italian astronomer Galileo Galilei who, in the early 17th century, made a groundbreaking discovery that would forever change our understanding of Venus and its place in the solar system. Using his newly invented telescope, Galileo observed that Venus, like the Moon, exhibited phases, waxing and waning in a predictable cycle. This discovery provided compelling evidence in favor of the heliocentric model proposed by Nicholas Copernicus, which placed the Sun, not Earth, at the center of the solar system. Today, with our sophisticated telescopes and robotic spacecraft, we know much more about Venus than our ancestors could have ever imagined. Yet, despite our advanced understanding of its nature, Venus continues to captivate us. Its ethereal beauty, a timeless reminder of the wonders of the cosmos. Whether it graces the morning sky, heralding the dawn as the morning star, or adorns the twilight shimmering like a celestial jewel as the evening star, Venus remains an object of enduring fascination. For those who take the time to look up and observe this celestial wonder, Venus offers a glimpse into the vastness and beauty of the universe we inhabit. It reminds us that we are part of something much larger than ourselves, a cosmic tapestry woven together by the laws of physics and the dance of celestial objects. Beneath Venus's captivating veil of beauty lies a reality that is both awe-inspiring and terrifying. The planet's surface is a hostile inferno, a realm of scorching temperatures, crushing pressure, and a toxic atmosphere that would be instantly lethal to any life forms from Earth. It is a testament to the power of nature's extremes, a stark reminder that the universe holds both wonders and dangers beyond our wildest imagination. As sunlight penetrates Venus's dense atmosphere, it becomes trapped by the thick blanket of carbon dioxide, creating a runaway greenhouse effect that has transformed the planet into a furnace. Temperatures on the surface soar to an astounding 900 degrees Fahrenheit, hotter than the surface of Mercury, despite Venus being farther from the Sun. This intense heat is relentless, baking the surface day and night, turning rocks to molten slag and evaporating any trace of liquid water. The atmosphere of Venus is a force of nature in its own right, a thick and turbulent shroud that dominates the planet and dictates its fate. Composed primarily of carbon dioxide, a potent greenhouse gas, Venus's atmosphere traps heat from the Sun, creating the extreme temperatures that bake its surface. This runaway greenhouse effect is a stark warning for Earth, highlighting the importance of maintaining a balanced atmosphere to support life. The clouds of Venus, a swirling mass of sulfuric acid droplets, are another testament to the planet's hostility. These clouds are highly reflective, giving Venus its high albedo and contributing to its extreme brightness in the sky. However, they also rain down sulfuric acid, a highly corrosive substance, creating a constant acid rain that would eat away at any exposed surface. Thankfully, the extreme temperatures on the surface mean that the sulfuric acid evaporates before it reaches the ground. But the threat it poses is a stark reminder of the dangers lurking beneath Venus's beautiful facade. Though no human has ever set foot on Venus's surface, robotic missions have pierced its veil, revealing a world shaped by volcanic activity. Vast plains of solidified lava, a testament to a turbulent past, stretch across the planet, punctuated by towering shield volcanoes and vast volcanic domes, evidence of molten rock pushing up from the planet's interior. These features paint a picture of a world in constant geological flux, a fiery furnace where the very crust is constantly being reshaped. One of the most striking features on Venus is Maxwell Montes, a towering shield volcano that rises to a height of 7 miles above the planet's mean elevation, making it the highest point on Venus. This behemoth dwarfs Mount Everest in size and serves as a reminder of the immense power of Venus's internal heat engine. Its slopes are thought to be covered in lava flows, testament to its violent past. To comprehend the dramatic contrast between Earth and Venus, we must delve into the heart of their atmospheres. These gaseous envelopes shrouding each planet dictate their climate and ultimately their destiny. While Earth boasts a life-sustaining atmosphere, Venus languishes under a dense, toxic blanket, a consequence of a phenomenon known as the runaway greenhouse effect. Earth's atmosphere, a delicate balance of nitrogen, oxygen, and trace gases, acts as a planetary thermostat, regulating temperature and allowing life to thrive. The greenhouse effect, a natural process, plays a crucial role in this delicate balance. Gases like carbon dioxide trap heat from the sun, preventing it from escaping back into space and keeping our planet warm enough to support life. However, this balance, as we are increasingly aware, is fragile and susceptible to disruption. The runaway greenhouse effect, the culprit behind Venus's hellish conditions, is a cautionary tale of positive feedback loops spiraling out of control. It's a phenomenon that begins subtly, but, once set in motion, can transform a planet's climate irreversibly. Scientists believe that Venus, like Earth, may have once harbored oceans of liquid water. However, as the young sun gradually increased in brightness, the amount of solar radiation reaching Venus intensified. This extra heat began to evaporate water from the planet's surface, releasing water vapor into the atmosphere. Water vapor, being a potent greenhouse gas, further amplified the warming effect, creating a positive feedback loop. The fate of Venus, though a seemingly distant world, holds profound implications for Earth. As we grapple with the growing reality of climate change, understanding the mechanisms that tipped Venus into a runaway greenhouse effect becomes increasingly critical. While Earth is not on the brink of becoming Venus, the underlying principles that govern both planets' climates are the same. The increase in greenhouse gas emissions, primarily carbon dioxide, due to human activities, is disrupting Earth's energy balance, leading to a gradual warming trend. This warming, if left unchecked, could trigger feedback mechanisms similar to those that transformed Venus, leading to potentially catastrophic consequences. For centuries, the surface of Venus remained shrouded in mystery, hidden beneath a perpetual veil of thick, impenetrable clouds. Early astronomers peering through their telescopes could discern nothing but a featureless, brilliant orb, its secrets tantalizingly out of reach. It wasn't until the advent of radar technology, capable of piercing through the obscuring clouds, that we were finally able to glimpse the hidden landscape of this enigmatic world. The first radar images of Venus beamed back to Earth in the 1960s revealed a world far different from the lush, tropical paradise some had imagined. Instead of verdant forests and shimmering oceans, radar revealed a rugged, volcanic terrain shaped by eons of geological activity. Vast plains covered in solidified lava flows stretched across the planet, punctuated by towering shield volcanoes and vast volcanic domes. Magellan's radar images revealed a Venusian landscape dominated by volcanic features, testament to a planet with a fiery heart. Vast plains formed by massive outpourings of lava cover nearly 80% of the planet's surface. These plains, known as planetae in the language of planetary geology, are thought to be relatively young, geologically speaking, suggesting that volcanic activity has played a significant role in shaping Venus's surface throughout its history. Scattered across these volcanic plains are thousands of volcanoes, ranging in size from small domes to towering shield volcanoes that dwarf anything found on Earth. These volcanoes, evidence of molten rock welling up from Venus's interior, have played a crucial role in shaping the planet's surface and influencing its climate. Venus's volcanic landscape is not just a testament to ongoing geological activity, but also a record of its violent past. The planet's surface is scarred by impact craters, evidence of collisions with asteroids and comets throughout its history. However, compared to other terrestrial planets like Mars and Mercury, Venus has relatively few impact craters. This scarcity of impact craters suggests that Venus's surface is relatively young, geologically speaking. Scientists estimate that the average age of Venus's surface is around 500 million years old, much younger than the surfaces of Mars and Mercury, which date back billions of years. Venus's atmosphere, a toxic shroud of carbon dioxide and sulfuric acid, has long been considered a realm of utter hostility, incapable of harboring even the most resilient forms of life. Yet even in this seemingly barren wasteland, whispers of something unexpected, something extraordinary have begun to emerge, challenging our assumptions and reigniting the flames of scientific curiosity. In the upper layers of Venus's atmosphere, where temperatures are surprisingly mild compared to the scorching furnace below, a team of astronomers made a startling discovery. Using powerful telescopes, they detected the faint signature of phosphine gas, a molecule composed of one phosphorus atom and 3 hydrogen atoms. This seemingly innocuous discovery sent ripples of excitement and skepticism through the scientific community, for phosphine, on Earth at least, is often associated with life. The detection of phosphine in Venus's atmosphere has ignited a firestorm of debate among scientists. Some remain cautious, urging further investigation before jumping to conclusions. They point out that phosphine, while often associated with life, is not a foolproof biosignature. Other non-biological processes, yet unknown to science, could potentially be responsible for its presence in Venus's atmosphere. Others are more optimistic, viewing the discovery of phosphine as a tantalizing hint of something extraordinary, a potential sign of life beyond Earth. They argue that the abundance of phosphine detected, combined with the relatively temperate conditions in Venus's upper atmosphere, warrants further investigation and perhaps even a dedicated mission to search for signs of life. Venus, with its captivating brilliance in our night sky, has beckoned explorers for centuries. Yet it wasn't until the dawn of the space age that we could truly begin to unravel the mysteries hidden beneath its veil of clouds. The journey to explore Venus has been fraught with challenges, pushing the limits of human ingenuity and technology. It's a testament to our relentless pursuit of knowledge, our insatiable desire to understand the cosmos and our place within it. The first tentative steps towards Venus were taken during the Cold War, a time of intense rivalry between the United States and the Soviet Union. In 1961, the Soviet Union launched Venera 1, the first spacecraft designed to fly past Venus. Though contact with the spacecraft was lost before it reached its destination, it marked the beginning of a decades-long endeavor to explore our enigmatic neighbor. While the Soviet Union focused on landing probes on Venus's surface, the United States took a different approach, sending spacecraft to orbit the planet and study its atmosphere and global features. In 1978, NASA's Pioneer Venus mission arrived at Venus, consisting of 2 spacecraft, an orbiter and a multiprobe. The orbiter, equipped with radar, created the first global maps of Venus's surface, revealing its diverse and dramatic topography. In 1990, NASA's Magellan spacecraft reached Venus, carrying the most advanced radar system ever flown to another planet. Over 4 years, Magellan meticulously mapped Venus's surface with unprecedented detail, revealing a world shaped by volcanic activity and tectonic forces. Its data revolutionized our understanding of Venus's geology and unveiled a host of previously unknown features, including vast plains of lava flows, towering shield volcanoes, and strange circular features known as coronae. As we conclude our ASMR journey through the scorching realm of Venus, we carry with us a sense of awe, trepidation, and a profound appreciation for the delicate balance that sustains life on our own planet. Venus, once envisioned as a twin of Earth, now stands as a stark reminder that even seemingly similar worlds can follow drastically different evolutionary paths. Their fates shaped by a complex interplay of geological, atmospheric, and perhaps even biological forces. Gazing upon Venus, we see a reflection not of what Earth is, but of what it could become. The runaway greenhouse effect that has transformed Venus into a scorching inferno, a cautionary tale writ large across the cosmos, serves as a stark warning of the potential consequences of unchecked climate change on our own planet. The dense carbon dioxide-rich atmosphere of Venus, trapping heat and driving temperatures to unimaginable extremes, underscores the fragility of Earth's delicate climate balance and the urgent need to address the factors that threaten to disrupt it. The exploration of Venus, a journey fraught with challenges and setbacks, is a testament to the indomitable spirit of human curiosity, our relentless pursuit of knowledge, and our desire to understand our place in the cosmos. From the early Soviet Venera probes that braved the planet's hellish surface to the sophisticated radar mapping of NASA's Magellan spacecraft, each mission has added a piece to the puzzle, gradually revealing the true nature of this enigmatic world. And the journey is far from over. A new generation of missions, armed with cutting-edge technology and driven by a thirst for discovery, is poised to embark on an even deeper exploration of Venus. These missions, equipped to study the planet's atmosphere, surface, and interior in unprecedented detail, hold the promise of unlocking further secrets and perhaps even answering the tantalizing question of whether life exists beyond Earth. The exploration of our solar system, a grand adventure that has taken us from the sun-baked plains of Mercury to the icy depths of Neptune's moons, has revealed a universe teeming with wonders beyond our wildest imaginations. Each celestial body, from the smallest asteroid to the largest gas giant, holds its own unique story, a testament to the boundless creativity and diversity of the cosmos. Venus, with its scorching heat, crushing pressure, and potential for harboring life in its clouds, stands as a testament to the fact that we've barely scratched the surface of what there is to learn about our cosmic neighborhood. As we continue to explore, we must remain open to the unexpected, prepared to have our assumptions challenged and humbled by the vastness and complexity of the universe we inhabit.